Greetings. In this lesson, we'll rig the crank and apply the lattice deformers to the overall box. Let's delete all our history at this point. Delete all by type history, so we have no more history in the scene. This will allow us to delete any extra history nodes and get rid of all the curves that we no longer need since the model is complete. And just a reminder, you should be doing File, Increment, and Save so that there still is a version with your history intact and the curves intact in case you needed to go back and make any changes. But as we proceed to the rigging and we assume that our model is done, we no longer need the history. So Edit, delete all by type history, delete your extraneous nodes. Also good to name the pieces so that we understand what it is that we're selecting. So first, I'm going to go ahead and hide these. I see that my crank is here. I'll go ahead and apply it to the object. And let's just talk about what making a surface live means. I'll just create a sphere, blow that up, and if I were to have a curve tool, let's say curve tool, CV curve tool, and I come out here and I draw across, the curve and the object are completely separate. I'll hit enter, done with the curve, hit delete. Making live means that the curve will stick to the surface. And this little magnet here at the end of all your snapping icons is make live. So I'll click on that. It becomes a dark green, and we could grab our CV curve tool. And now when we draw, you see that it is on the surface. I'll hit enter when I'm done. And a common mistake is to forget to make the surface unlive. So we want to make sure that we come back and deselect that, otherwise everything else that we do in the scene would be snapping to this sphere. But now we've got a curve on the surface. We're going to, and so you could practice that, make a surface live, grab a curve tool, draw on it, make the surface unlive, just to make sure that you understand that, that process. The other thing that we'll be doing, I'm going to go ahead and create another curve, is creating a path. So you know that if we have an object and a curve, I pick the object first and the curve second, and if we come to deform, come to the rigging mode, constrain, motion paths, attached to motion path. So I'm in the rigging mode, constrain, motion paths, attached to motion path. I'm going to open the dialog box, and I'm going to just hit reset. And let me just demonstrate this again. Pick the object first, the path, and then hit attach. And if we were to press play, we see that that object is now following the path. So that is what path animation is, or attaching an object to a path in the default mode. I'm going to hit undo till we get that back, and constrain motion paths, attach to motion path. This time, rather than choosing time slider, or if I put start in, you could type in the numbers there. I'm going to come and just choose start, and we'll hit attach. And what that did was, you can see if I press play now, there's no animation. The object is simply attached to the curve, and if we were to come and pick a vertice, and let me go back to that one, we can move the curve, and you see that that object follows it. And I could come to this curve, and we can move it. And so there are lots of instances where you want an object to be on a curve. A pretty classic example of this is creating, say for instance, a pearl necklace, where we attach many spheres along a curve, offset each one of them, and then you can move the curve and it functions like a pearl necklace would. Another example is a button. So a button on a deformable object. The object will deform, the button will follow, but the button itself wouldn't deform. So that's another kind of standard example. What we're doing is having our handle follow the deforming box. The handle itself we don't want to deform. We want it to rotate and appear as a solid object. But as that box deforms, according to a lattice deformer, we need the handle to follow along. So I'm going to, and try that. Just pick an object, pick a curve, and choose attach as the default, as an option. Constrain motion path, attach to motion path. Choose just start, and see if you get the hang of that workflow. I'll right click to object mode. We'll get rid of this and bring back our elements, and let's give it a try. So I am going to hit the 5 key. I'll grab my box, right? I'm going to hit the Q key. I don't want my move tool on necessarily. And oh, excuse me, before we make this live, we need something to snap to. So I'm going to come back to the crank. We'll open that, and we're going to say display, transform display, selection handle. And now with that little handle on, I have something to snap my curve to. Now I'll pick the box, make it live. Note that it turns dark green. I'm in the 4 mode actually. And we're going to create an edit point curve. Remember that a CV curve takes 4 clicks to generate. It needs at least 4 vertices. The edit point curve tool allows you to generate a curve with just 2. So anytime you want to make a straight line, the edit point curve tool is your go-to. I'm going to hold down the V key, right? The V key for vertex snapping or point snapping, and I'll click on it, and I'll snap on it with the V key, holding down the V key, clicked on that. I'm going to hit undo, hold the V key, and you can just shake it around, right? You see that it's trying to snap to some things over here, but get it to snap to that exact handle, right? We move around, I'm holding down the V key, and it is snapped on there, the first vertex of our edit point curve tool. And then I'm just free snapping the second one. Didn't hold anything down. Hitting enter when I'm done. Zooming out a little bit, and then we're going to make the surface unlive. So very common to leave the, forget that this is on and leave it on, and then you've got things snapping to the object. Now, before I proceed, we don't want to actually attach this node to the curve, excuse me. We want to give it an additional node. So this transform node we're going to use to rotate the handle. If we were to attach this node, crank extrusion, to the curve, then we wouldn't be able to animate it directly. When an object is attached to a curve, I probably should have mentioned that a moment ago, its transform is handed over to the curve, so you can no longer directly key it. We'd like to be able to directly key this, so we'll just simply group it to itself, edit, group, I'll hold down the shift key, hit the plus, and so we can see what we've got in this. We've got our crank, right, we've got the handle out here. Here is the extrusion that it's parented to. And now we have a brand new node that we will attach to the curve. If we hit the move tool, though, we see that the pivot is at the origin. By default, when a new node is created, the pivot is at the origin. So I want to move this pivot to the same exact place. And while we have the handle on, that will be easy to do before we turn the handle off. Now, in the video, it says to hit the home key. But if you're on a PC, I believe it's the insert. And then my keyboard, for instance, doesn't have a home key. There's another shortcut. I probably should have used that one in that video. Although home works, insert works if it's on your keyboard. But the D key is also the option for changing the pivot. So you can see here I'm hitting the D key. That changes to the pivot transform handle. And I can move that around, right? I'm moving that around, picking it in the middle. Also note that you see all 3 colors, green, red, and blue. If you inadvertently were to pick one of those, you'd be limited to that. So we want to snap in all directions. Make sure that you're seeing green, red, and blue. If you accidentally click on one, just let go and redepress it, and it'll give you all three colors. Now I want to snap to that handle. Remember that V and our middle mouse button. So I held down V and the middle mouse button. If you want to shake it around just to make sure you could, but D key and V key simultaneously, middle mouse button, and now I've snapped that to the handle. And I'll come back, right? This handle isn't for the group node that we created. This handle is for the crank extrusion. So this is sometimes a mistake that students make where they think they're turning this handle off, but they're actually turning the handle on for the group one. Come back to the crank extrusion and display, transform display, selection handles, turn that off. So we haven't made the attachment yet, but we've cleaned everything up. We turned on a handle for crank extrusion. That allowed us to snap the curve to it. Then when we made our group, it also allowed us to snap the pivot for the group to that handle. Once we were done using the handle for those two things, we turned it back off. Now we'll attach the crank to the curve. We've got this selected here. In fact, if we want to call this, let's say crank path, and I'll even capitalize that so we can remember it, crank path, this is what's going to be assigned. We'll pick this first, shift select the curve. Now note that the curve doesn't highlight in the outliner. It's not listed in the outliner, but again, we'll pick the crank path, right, our new node, not the sphere, not the extrusion, but that new group that we just created. Shift pick this curve. We'll come up to constrain, motion paths, attach to motion path, open the dialog box, and we'll choose start. I'll hit attach, and you see that it flips. The object has an orientation, and it doesn't know which of the 6 axis directions it should go. So I'm going to hit the undo. If you wanted to reselect, you could. Crank path, shift select the curve, constrain motion path, attach to motion path, and the front axis is actually the Z. So we'll choose Z, up is Y, we'll hit attach, and there we have it. Now it might not appear as though anything's happened, but you can test this by coming and grabbing the vertices of the box. Now my soft select is on. I'm going to hit the B key. B key turns soft select on and off. I'll grab this and we'll scale it. Oops, and it looks like my symmetry is also on. So I'll turn that off. I'm going to reselect. And I could tell that my symmetry was on because my pivot wasn't in the middle of this selection. So I had selected both sides, it was selecting both sides, and you could tell that the pivot was offset slightly. So I knew that my symmetry was on. Turn that off, and you can see we can deform the object. This group of objects follows, but itself does not deform, right? So it's following as an object, but it itself is not deforming. We'll hit undo. All right, so you might want to pause at this point in the video, go back. You can follow the video 4 in the playlist. The other thing I'll mention, right, taking notes during these lecture videos so that you can remember, for instance, that D is equivalent to the home key, C is curve snapping, V is vertex snapping. Those types of things, you will jot it down so you don't want to have to come back and watch the entire video again. All right, let's proceed to the deformation. And there's one thing in the video that I think isn't clear. The videos are annotated well. I'm using the lecture to give a general explanation and review the process. But one thing that I don't think was clear in the video is what we're selecting when we create the lattice deformer. And in fact, let me just give a quick overview of what a lattice deformer does. We've used the lattice deformer in that first semester, but we may need a reminder. I'm going to come and just make a sphere, and to demonstrate, let's say we were trying to pull out the rear, maybe make more of a skull type shape. Maybe we were using this as a head, we're looking at the profile, and we want to kind of pull out the rear of the skull or cranium. If I pull that out with polys, right, it is, that's not a very good selection, but sorry about that. Let's go ahead and make a good selection. If I were to grab all that, I'll use the control key to deselect and pull that out. You see that it's has a hard ridge. So what the lattice allows us to do, I'm going to come up to deform lattice, deform lattice, and I'm just going to make 3s in my divisions. And if we were to now come and just pick this one point, you see that it's averaging. It gives us one vertex and it averages, and we could then kind of pull that out, and we've got more of a profile. Maybe we want to pull that up, pull that in, pull that out. So it allows you to give a generalized shape to a more complex shape. It is a lattice deformer with fewer points than are on the actual object that allows you to create a generalized shape. So that's what a lattice is. If you want to make an object, create a lattice, you can play with changing the divisions. The other thing to note is that if I want to maintain the deformation and get rid of the lattice, I would delete the history. In other words, if I just pick the lattice and delete it, you see that the shape snaps back. If I pick the surface and say delete by type, history, then that goes away and the deformation is maintained. Go ahead and delete that. All right, let's bring our box back and let's create that lattice. And as I mentioned, I don't think the video is as clear as it could be on what is selected when we create the lattice. And so look here in your outliner. So here's my, I'm calling it a ridge for lack of a better term. There's my circle top, the circle loft, the box itself, and then we've got the hinge. I'm going to open this. All of these, the planar, the two planars, the loft, and the caps are parented into this cylinder. So I don't want to have all of that selected. And I think that video may have not been clear on this step. We only want the elements of the box and the cylinder, but not the things that are parented to the cylinder. If I have those selected, we'll get a double deformation. My deformer will deform all the elements of the box top, plus its parent, the cylinder, is being deformed. And so it won't, when we go to deform it, it'll fall apart, it'll pull apart. So if you're to that point where you're deforming the overall box and the box top is coming apart, what most likely happened is when you created the lattice, you had all of those things selected. When in fact, all we want are the elements of the box, right? Those are all the elements of the box, and the cylinder. I've named it here box hinge, but it is that cylinder. And you can see that these are all the pieces that are parented to that cylinder. So all the elements of the box and the cylinder, but don't manually select or don't bounding box select. You see that these elements are highlighted. It looks like they're selected. They're technically not selected. Their parent is selected. And we also don't have the crank at all selected. None of these three nodes are selected. So the elements of the box and the cylinder will come and we'll say, in the modeling mode, we'll see the deform, and we can come to lattice, and we see that it is hugging the box nicely. I'm going to go ahead and hit undo and show you another problem that may have arisen. In the first movie, I had you pull that handle out, and that would cause problems. Let me show you what that looks like. So if I come to Display, Transform Display, Selection Handle, I come into the component mode, make sure handles are on. I'm going to turn my vertexes off, and I pick that handle, and I move it out, and we come back, and so that's where we left it. It's a good idea. It's standard rigging practice to have your deformation handles out here, and we were just making it so that it was easy to select. But if I did that same process now with this handle out here, and I came up to deform, create lattice, you see that the lattice is extending all the way out to the position of that handle. And now our deformation wouldn't be at the center of the box. It would be offset. So we don't want that. I'm going to just hit undo. And so if you're at this point and your handle's still out here, all you have to do is pick the handle, go into component mode, make sure handles are on, we'll pick it, and we'll just slide it back. We are eventually going to leave it out here, so don't be too worried about where you put it. Just put it somewhere there in the middle. Come back to object mode, and then we want to turn it off. Display, transform display, selection handle. Now we'll pick again all the elements of the box, the cylinder, deform, lattice, and you see that it's nice and tight on the box. Now we will continue rigging. Remember that rigging is always twofold. It is the mechanics of the rig. So for instance, we've created this deformer that will deform the box, and we can animate those lattice points directly, but that wouldn't be the easiest thing to do. We don't want to have the animator, or if we're the animator, fishing around for selections that we are doing repetitively. So anything that's done repetitively, you want to create some type of mechanism for ease of use. So we've solved the mechanical problem by creating this deformer. Now we're going to make it easy to use by making a cluster of the related lattice points and then offsetting a handle for that cluster. So we can test as well. We'll come and pick the lattice points all the way around. All 4 of those. And we're just scaling those positions. And you can see that our crank is following. That works well. I'm going to hit undo. A cluster, deform, create cluster, second one from the top, is just a set of vertices. It can be any kind of vertices. It's typically used by selecting a series of vertex or vertices, making a cluster of it, and then you can weight it. This is used in facial rigging all the time, and we'll use it when we ultimately rig our jack-in-the-box face. So just remember that a cluster is a set of vertices or vertexes. I'll hit deform cluster, and you see that C is there. We've got the cluster handle, easy to select, and then easy to deform, right? That's much easier than trying to go around and pick those 4 lattice points each time you wanted to animate them. We can just hit the cluster, select the cluster, and we can scale that. Now, excuse me, we'll go ahead and turn on a handle, display, transform display, selection handles, and we'll come into component mode, make sure that we've got our handle on, come out here, and we'll offset that. We'll repeat the process for this next one. We'll come back to object mode, right click, and now we'll pick the lattices around the top of the box. So picking all 4 of those, and we'll deform, create cluster. We've got our cluster there. Easy to select in the outliner, but let's make it easy to select in the interactive space. Display, transform display, selection handles. I want to offset that handle, come into component mode, handles are on, I'll pick the handle, and I'll slide it out. Now remember, if we want these to be exactly lined up, I will pick the axis I want to snap to. Holding down the V key and middle mouse button, I snap to this, and now these 2 handles are perfectly in line. Yeah. And so now we can see this is going to rotate to and fro, and this is going to breathe. And I'll pick my box hinge and we'll rotate that. Oops, wrong one. We'll rotate that down. Oops, sorry. Let's see. I thought that was one of those. That is rotate X. So we've rotated that down, and we can check. And so you can see that we can rotate this back and forth. We can scale this. And the two things to check when this deformer's working, our crank is following, but it's not deforming. That was the first half of this lesson. And the second is that when we grab this handle and we rotate it, the box top isn't falling apart. We're not seeing any gaps. And that was the whole notion of making sure that you were picking, when you created the deformer, just the elements of the box and just the cylinder, not the elements of the box top that are parented to the cylinder, not having those selected. If your box top is coming apart at this point, you'll have to go back and execute this part of the lesson again. Okay, questions in the tech discussion forum? Yeah, have a good one.